content is about chapter 2, heat transfer in building. So I will go a little bit on lecture, and then we also will do some calculation. And chapter 2, heat transfer is quite important, and many question, favorite question, chapter 2 about calculation. By the way, I would like to remind you that our test will be on 27 April. So 1 week before Raya. Hopefully all of you can join. So 27 April night time. Okay, hopefully if you have any problem, please inform me, because all the other section is okay with that day. All right. Okay, just to be informed again, our test will be 27 April, Wednesday night from 8:30 p.m. Okay, the next thing information that I would like to inform you is by 19 April, I will give some talk or webinar during 19 at 2 p.m. So I would like, so we will change, the class will be to join the webinar, because the topic will be thermal comfort, which is some of topic inside chapter 2. So I will cover in topic 2, thermal comfort, I will cover later, which will be inside the webinar. All right. Okay, without further ado, let's go for today's topic. All right. Fundamental of building physics. But before that, I've just found one software to record. Let's see if it's okay or not. All right. Okay, first, so now I open to Google Meet. Hopefully, can you give feedback? Can you see the slide clearly and can hear me clearly?
Yes.
All right. Okay, thank you. Okay, I will share this to you, the slide later. Okay, fundamental of building physics. So this is an important chapter which located in chapter 2. So why in building physics we will learn about heat transfer in building, heat transfer in building envelope, and mechanism of heat transfer. So why this chapter important, and what is the relation of this topic with mechanical system? So basically, one of system that really need to consider the heat transfer is air conditioning system in building, or thermal comfort in building. So inside a building, what we call it as a building envelope. So imagine this is a cross section, a simple of building, right? So one of some of recent technology is to get air conditioning for building cooling, right? So, but if the indoor condition become too hot, so what happen is we need more energy. Okay, we need more energy for cooling. Therefore, the best way to use air conditioning system is to at least to provide a good building envelope that can slightly reduce heat going inside to the indoor condition, and therefore we can enjoy a slightly better indoor condition. And also, if want to use energy, air conditioning for cooling, we can reduce the energy for cooling. So heat transfer, we will learn about how to prevent or reduce heat transfer through the building envelope. Okay, we call it as a building envelope, ruang lingkup bangunan. Okay, we can see here in this slide, why we study heat, because building envelope, when the building envelope less absorbed heat, it will lead to less energy for cooling. So the target is for building is to achieve thermal comfort and energy efficient in cooling. All right, I will go slightly faster. So what you want to understand in this chapter we will deal about heat. So heat is a form of energy appearing as a molecular motion. It will measure as a joule, and then we will always use temperature, and then unit of temperature is degree Celsius. All right, and then we have something thermodynamic law to understand. Number one is the first law of thermodynamics is the principle of conservation energy. So energy cannot be created or destroyed, but it can change from one form to another form. So These things you need to understand, or not to understand, but you have to accept the fact that the energy cannot be transformed, but it can change from one form to another form. So, for example, from heat to electricity, okay, from force of water flow to electricity, okay. Okay, number two, the second law of thermodynamics is heat heat transfer can take place in only one direction only, which is from hotter to cooler body. So second law of thermodynamics, if you have a road, steel road, and you add some uh, heat in at one edge, and then what happens is the heat will transfer from hot to cold place. So only one movement area. So there will be no from cold to hot. Okay. All right. Next things is okay, how heat being transferred. Okay. So as you can see here, there are three ways the heat can be transferred. Firstly is by conduction. Number two is by convection. And lastly, by radiation. So let's see what is the difference between each of a heat transfer method by looking at this figure. So let's see conduction. All right, conduction, the figure shows at the holder. It means conduction is heat transfer through solid material. Okay, for example, this water pot, being heated by the fire, and then the base, it will become hotter, and it will transfer through all the material, solid material. It will transfer from from hot to cold place, but in the end, all the pot will become hot. So in this process, transfer from place to place within solid material is called conduction. Okay, so but if this holder is a steel, so the hand will feel hot. But if because the holder is normally by wood, so wood is a very good heat insulator, so we can hold the pot. Next is a convection. Okay, convection is the heat transfer through fluid. Should you see here at the bottom of the pot, the surface of the pot become hot, and it boil the water molecules near to the surface, right? Okay, and then the boiling water or the hot water will transfer the energy or the heat through the heat will travel between the molecules, okay, from hot to cold place, and then it will create an convection. So the hot the hot water or the boiled water will become lighter. Okay, the density become lighter, and it become you can see the bubble, right? So the hot water will go up, and then the cold water, which is slightly dense, have because it's cold, it's dense, it will fall down. Okay, the hot water become lighter, less density, it will going up. So when this cycle repeated many times, so until certain period of time, all of the water become a boiling temperature. So, but this process, heat transfer within fluid, is we call as convection. Okay, convection not only happen within fluids, but it can also happen in the air. Okay, heat transfer through air also we call as convection, because in the air we also have some humidity. Okay, and it will transfer from one place to another place. Okay, last but not least is radiation. So how heat being transferred by radiation is through the electromagnetic wave from the fire. So the fire have light, okay? Light radiation, cahaya, lighting. So the lighting have some we call as a electromagnetic wave. Sorry, okay, electromagnetic wave, short wave radiation. So because it has short wave radiation, it can contain some energy, right? So it become hot. It will you will find near to the fire some heat because of the radiation. So basically, there is about three ways how heat been transferred. Okay, the next slide shows summary. Okay, for example, for conduction, okay, conduction. So it is heat transfer between solid material. For example, we have material one, material two, and it touch. The heat will transfer from hot to cold place. Okay. Meanwhile, in a fluid, air or gas, we call it as a convection. Okay. So if there is one hot plate, okay, 50 to 45 degrees Celsius. So what happens if there is air near to the plate? It will make the air hotter. Okay, just adjacent to the plate. Okay, last but not least is radiation. It's simple. Is a simple example is through the sun, which is a electromagnetic wave through the sun. So we can get the heat energy. Okay, when we relate to our building, how heat being transferred to the building, we can refer to this slide. Okay, we can say that there are two ways. Firstly, maybe during daytime. Okay, during daytime we have a hot sunny days. So what happened is the roof, okay, roof receive very hot direct solar radiation, direct solar radiation. Okay, so what happened? The surface will become hot until certain time. Okay, and what happened if normally roof have several layers or maybe just one layers, which is roof tile. So what happened after reaching the roof surface, then the heat will transfer through inside through the material by conduction. Okay, we start with electromagnetic wave radiation. Until it reach the surface, it will change to conduction. Okay? Conduction. And then the conduction, it will flow by conduction, it will flow through all the um, building structure. Okay. Heat slowly, heat will transfer from hot to cold place. All right. And then in the same time, for example, inside the roof, until certain time, the inside layer of the roof will become hot. Okay, and then it will also, after some time, if too hot, it can re-radiate to inside. Okay, it can also re-radiate. Sorry, re-radiate to inside. Where is it? To ceiling. So what happens if it re-radiate to ceiling? Then it will become make the ceiling hot, and then the hot ceiling will re-radiate the uh, heat inside the room. Okay. So what happened here is a combination of solar radiation and also uh, conduction inside the room. Okay. And if you open the window, in case of there is a window and there is a blows of hot air, so we will say that the heat brings to the house by convection, right, through the infiltration of hot air inside the room. Okay, all right. Okay, until now, can you understand the process yang apa related to all the mechanism? All right. Okay, no problem. Until now, it's okay. All right.
So far so good.
Okay, Doctor.
Okay. Next is how about nighttime? So nighttime, the outdoor condition already cold. So what happened is, for example, around 7 to 8 p.m. So outdoor or slight now from sunny become dark, and then what happened? The building structure still hot, right? Okay, but so what happened is when outside is cold, the the heat will release to the cold area, right? Heat always find its ways to colder area. So what happens is we release the heat through outside, and if inside indoor area is cooler than the structure, it will release to inside. Okay. So what happened here, if it is okay, no problem, we want the heat to release to outside. But some cases, the heat will release to inside because indoor temperature is cooler than the substructure. So it will find cooler place, right, to transfer. So if during nighttime you have lack of ventilation, for example, lack of openings, you not open the window or not good ventilation. So what happen? The heat will trap inside your house. Okay, so when the heat trapped, so the heat will conduct from the warm air to the ceiling. Okay, so when the indoor condition hot, it will make the ceiling hotter and conduct the heat to the attic area. And then the heat conduct through the ceiling to the attic, and the convection cause warm air to rise and the heat is lost. Okay, and then of course in this process, the heat will release to the attic area and to outside. Okay, but it will take time. But if you can open the window during night time using night ventilation, so you can get the cooling condition much more faster. Okay, all right. That is things that you need to understand how these things works. Okay, convection, conduction, and radiation. Okay. So normally in house, as a building, we have, I hope you can understand what is roof, what is floor slab, what is wall, what is window and doors. Because this we call as a building envelope is where the normally the heat being transferred by conduction or radiation. So during daytime, source of heat gain normally glass. Okay, mainly the solar can enter through the glass. Okay. Number two, followed by walls and doors. Number three is people activity, because we have metabolic rate. When we do activity, we will release heat. Similarly, if a small room, if you live only one person, maybe it takes time to get hotter. But in the similar same small room, if you invite 10 people in the room, so you can feel very warm, maybe in less than 15 minutes. Okay, because of activity and release of heat. Next is crack and leaks. What is crack and leaks? Crack and leaks means if there is imperfection, or if your wall has some cracks, small hairline cracks, but the hot air can infiltrate through the cracks and leaks, and then maybe leaks underneath the door, on some small opening in the building. Last but not least is the ceiling. All right, ceiling of the whole house. So when you know this, where is the source of heat will come through, so you will, when if you want to tackle the problem, you know what should we prevent first, right? So as for example, in this example, we know from glass, so during daytime we should provide some external shading, for example. All right, but and maybe we want to provide a very good thermal resistant glass. Okay, okay, that is during daytime. Okay, during nighttime, uh this one. Okay, during night time, the heat will there is a weak heat loss from building. So let's see, number one. Okay, during nighttime, heat loss mainly from walls. Okay, around 35%, followed by roof, 25%. Okay, and then windows, 10%, and then draft and of total heat. Okay, draft 50%, and lastly to the floor. Okay, so for nighttime, mainly from walls lah. Walls, roof, and windows. So three important places. So if you can uh, make sure the energy can be released effectively through these three parts of building, so we can achieve a cooler or very comfortable condition during nighttime, earlier or faster. Okay, now already 20 minutes of lecture. I will stop 5 minutes. Let's we continue later after this. So make sure you not too jam. So what you have to do during these 5 minutes, just to recall again the type of heat transformator. Okay, and then heat a source of building. Okay, we break 5 minutes. We will continue at around 2:33. 2:33. Okay. Okay, I think I can continue now. So previously, 5-10 minutes ago, we learned about heat transfer method through conduction, convection, and radiation. But there is one more thing about heat, which is type of heat, such as sensible heat and latent heat. Right. This is quite important also to relate with the air conditioner later. Okay, what is sensible heat? Right, let's read first. Sensible heat is when object is heated, its temperature rise as heat is added. The increase in heat called sensible heat, right? So again, the temperature rise as heat is added. Okay, so for example, again, we have a metal block. We have metal block. When we add heat, 50 degrees Celsius, the temperature of the block directly increase from 0 to 50 degrees Celsius. Okay, directly increase. So what happened? That is a sensible heat. Temperature rise as heat added, or temperature reduce when heat remove. So they eat directly. We call it as sensible heat. Right. Again, similarly, when the heat is removed from object and its temperature fall, the heat removed is called sensible heat. Right. Everything is about instant increase of temperature or instant reduce of temperature when uh, temperature is added or when temperature is removed. That is sensible heat. Okay. Number two is latent heat. Latent heat is hidden heat. This is there but hidden. Okay. Why is hidden? It is term used for the heat absorbed or given by a substance while it changes its physical state. So what can we say is latent heat is heat absorbed to change physical state. Heat absorbed to change physical state. Right. Okay, let's say this example. We have frozen ice. Okay, what happened here when we add? Okay, first thing first, we start here lah. Okay, firstly is 0 degrees Celsius, which is frozen. When we add heat to the ice. So what happened? Temperature of the ice increase proportionally until sorry. Eh, okay, sorry. Let me start from earlier. Okay. Okay, during frozen, okay, when we add heat. What happened is temperature increase. A similar situation lah. So what happened to the ice is actually melted. The ice will melted. Okay, during this phase, all right. What happened here? Okay, here we add heat, plus heat. So from the frozen ice block, temperature increase until certain time, temperature remain the same. For example, at 0 degrees Celsius. So what happened in this temperature is the ice melt from solid to liquid. So there is a change of form from ice to liquid. So what we call it, this is a latent heat, energy that used to change the phase. Okay, all right, no problem. We check again another example. So after change to total liquid, so when we add more heat, what happened? The water will become hot that until it reach 100 degrees Celsius. So what happened? And then what happened is the water become boiling water. It will reach until 100 degrees Celsius only. Because what happened here is a change of state. State. So the heat still there. There is a 100 degrees Celsius heat. But what happened is it cannot be more than 100 because during this state, energy being used to change the liquid to gas. Okay. So what happened here is the liquid, the boiled water changed to gas. So that is what we call latent heat. Energy that required to change from from solid ice to liquid, and then this the energy that required to change from liquid to gas. Okay, to relate what happened in the air conditioner system, because in air conditioner system, aircon, in our room, in the building room, we have relative humidity. We have humidity inside the room. So if the humidity is too high, the level of humidity is too high, if we require a lot of energy to remove the humidity. So how to remove the humidity? Needs a latent heat to remove uh, the gas to water. Okay, reverse condition. Still, to reverse this condition from gas to water, we still need latent heat. Okay, or latent load. Latent load. Okay. So you can read here later in this box. All right, that is about sensible and latent heat. Okay, this is example of sensible and latent heat in the building. Okay, so latent heat comes from the air, okay? Hot air or humid air. Okay, and people also has a respiratory system that can melepaskan humidity, right? So it is source of latent heat. Okay, I think I will stop there for type of heat transfer method and type of heat. So what I want to continue now is to calculate how to measure, to calculate heat through the building. So again, as I mentioned before, we have three types, right? Conduction, convection, and radiation. And all of these, we actually can calculate how many convection energy through our home, how many radiation energy. But honestly, in this course, we will focus only on conduction. So convection and radiation, we will not consider in our calculation because it's too complicated, all right? And the equation is too complicated. So we will focus only on conduction. Heat transfer through conduction. Okay, let's see what question that we have. Okay, so all right, before we use this equation, we want to know important things. Thermal conductivity and resistivity. Maybe I will draw here. Okay, imagine we have building, again, simple building. And then we have a building material. So for example, here is a brick. Normally brick and plaster, right? Plasters, brick and plasters. So when we say about building material, so each building material has its properties. Okay, heat transfer properties. So what we call it as number one is K value or thermal conductivity. Sorry, K value, or sometimes people use lambda value. Okay, so number one important thing to know is we have thermal conductivity value and resistivity. So what happened is every material for the building has a K value. So brick has its K value, plaster has its K value, and then for example glass Glass has its K or U value. So all of these building properties has heat transfer value, so we can calculate. Right. So the value is depend whether the material is conductance or insulator. For example, we see this table, this one. Okay, we have the materials such air, wood, mineral, and rubber, and so on. So if you can see the thermal conductivity value smaller to bigger, going down the table bigger, which means diamond, silver, copper is the good heat conductor. Right. So, but in term of limiting the heat, so we don't want conductance. We want insulator for building. So, for example, air, wood, mineral oils, less than one, thermal conductivity. So, by the way, if in case of you have to design, you have to propose uh, green building design, green building envelope. So you need to find through standards what is the typical K value for brick and so on later. So the unit is watt per meter Kelvin. So again, K value is watt per meter Kelvin or watt per meter degree Celsius. So what is K value is for example, we have brick. Okay? How how many watt can be transferred through the brick? How many watt? So for example, for the brick, how many watt can flow through a unit of brick? So each of uh, building elements have its own K value. All right. For example, normally normally we have brick and plaster, right? And plaster layer at outside. Okay, so brick, for example, 100, plaster is 25, plaster and 25. Okay, so the brick have its K value, and then the plaster has its K value. So when combined, it will create resistance. When combined, it will create resistance. Okay, resistant to heat. Good. Then we can call number two is resistant. Okay. Thermal resistant. Thermal resistant is R. Okay, it can be thermal resistant based on one material. Okay, for example, brick. Only one brick has its K value, and to calculate the resistance of the brick, for example, the brick is 100. Okay, so we use the equation of D over K, right? Which is D in meter. Okay, maybe I draw here lah. The flow that you may need to know is first is K value, understand K value. All right. Number two is to calculate thermal resistance. Thermal resistance. So thermal resistance can be calculated by D over K. Okay, this is if one material. So D over K. D is thickness actually. D is thickness in meter. Okay, if I have brick which is the thickness is 100 millimeter, and the K value of for example 0.08 watt per meter Kelvin. So what is the resistance value? Our thermal resistance it is D over K, which is convert to meter. 100 is 0.1 divide by 0.08. Okay, so here you can get I don't know, I don't have calculator. Okay, calculator 0.1 divide 0.08, we can get 1.25. 1.25. Okay, the unit is watt per meter squared Kelvin, right? Because D is meter, sorry, meter squared Kelvin over watt, because R equal to D over K. D is meter, K is watt per meter squared Kelvin, right? So it become meters, sorry, meter Kelvin. So it become meter squared Kelvin over watt. So this is thermal resistance. So maybe in the slide we have some example. Okay, right, like this, eh? Okay, maybe for example we have glass 6 millimeter, concrete 300 millimeter, rock wool 80 millimeter, right? Different thickness, different material properties, different K value. So let's see which one provide better R value. So R value we require high, high. The bigger R value is better. Okay, let's see. Okay, for glass, thickness is 6 millimeter, so convert, which is 0.006, divide by 0.8, we can get 0.0075 meter squared Kelvin per watt. Okay, then we look at concrete. Concrete, 300 millimeter thickness with thermal conductivity of 2, so we can get 0.15. Meanwhile, this is a rock wool, which is insulation, only 80 millimeter thick, but it has very small K value, 0.04. So what happened? A smaller thickness, but different material, resist very low K value, so it can provide very strong R value. So the relationship is R equal to, sorry, R equal to thickness over K, K value. So to improve R value, it can be two ways. Either you can increase the thickness or you can lower the K value. So if you lower K value means you use insulate better or insulator material. So lower K value is reciprocate, berkadar songsang. R increase is, which mean K value is reduced. Alright. But R and thickness is directly proportional. If D increase, R will be increased. Okay. So that is about K value and thickness. Okay, before we going further, let's do this number one exercise. Okay. Calculate. Calculate the thermal resistance for each of the following material and then identify the best resistance value. So the equation is uh, R equal to D over K. Okay, try to find it in maybe 6 minutes. Okay. Okay, ada yang dah berjaya jawab? Ada yang berjaya menjawab? Okay, inform me. What is the R value for light concrete? Light concrete LC. Huh? R value of brick. R value of polyurethane. Okay. Alright, we have some answer there from a link, second link. Okay, Zari Salina, 0.083. This is for what? For lightweight concrete or for brick?
Light concrete.
Okay, lightweight concrete 0.083. So remember the units, m squared k over watt. Right, for brick is 0. Okay, Haikal Nazira give 0.22 meter squared Kelvin watt. Right, last but not least is for polyurethane. What is polyurethane? Polyurethane is insulation. Okay. Insulation, I expect smaller. So can you calculate? Alright, 1.429. Okay, good. 1.429 meters per Kelvin. So hopefully you all of you get this. How to calculate? How to calculate? Very simple. Just use this equation. R equal to D over K. D is thickness in meter. Meanwhile, K is the K value. Right? Just divide it. So based on this, which one is the best resistant value? Right? So again, the best resistant value is the largest value. Largest resistant means the best resistant. So we can see here that the largest is number C lah, polyurethane foam, which is 1.4. And secondly, followed by brick, and lastly is lightweight concrete. So we can see even though brick is very thick, but because the K value is smaller than the polyurethane foam, it still cannot match the thermal resistance that can provide by polyurethane. Okay, next. So next exercise is about how to calculate resistance as a unit, because it's as a building structure, it is impossible to create by only one material, right? Normally it's combination of several layers. Okay, let's see how to calculate thermal resistance as building units. Okay, for example like this. Okay, so normally in this case we have plaster and then brick and then okay, plaster and bricks only. So but we also need to consider surface, inside surface temperature and outside surface temperature. Okay, how can right? Okay, normally to calculate R total, we if have several layers, okay, so we have layer 1, layer 2, layer 3. For example, layer 1 plaster, layer 2 brick, layer 3 plaster. Okay, so similar as previous. So we have plaster, brick, plaster. So how to calculate? We have to calculate as plaster. At the one side is R1, brick is R2, another plaster is R3. Because for example, the heat, for example, heat will transfer through the wall. It will transfer to all layers. It will consider all layers. So to calculate R total is summation of all the layers. R1 plus R2 plus R3. Okay. This is basic, but normally we have to add. We should consider air resistance. air resistant or surface resistance. Because normally, for example, we have wall surface, very thin line adjacent to the wall. We actually the air adjacent to the wall, it has a, we call as a surface resistant. Okay, surface resistant. So in here, surface resistant, if you have a house or room, sorry, the drawing is not very good, but example, this is a wall, this wall, so heat from outside, hot condition. So at the external surface, it has a surface out resistant. Meanwhile, at the inside also, near adjacent to the wall, has a surface inside resistant. Okay, and then this is about surface resistant. Meanwhile, number two, we have also airspace, airspace resistant. If you have a brick, and then uh, brick outer leaf, brick outside, brick out, and brick inside, brick inside. So inside here is a gap or air. What happened here is this cavity can become resistant because the air is a very low K value. So the air itself can become resistant. Okay, but normally we have a surface resistance. So what we have considered now is, for example, this equation, we need to consider surface out resistant plus surface in resistant. So normally surface out and surface in given, then value will be given. Okay, will be given. If the value no, if there is a question, the value will not be given, so you can ignore. Okay, you can ignore the S value. But in actual calculation, in actual life calculation, you need to consider surface resistance. So let's see this exercise. Alamak, saya terpadam ke? Alright. Okay, calculate the thermal transmittance. Alright, sorry, this I already calculate the R value first. Okay, ignore this. Ignore this. It's based on this figure. Calculate R value. Okay. Uh, so outside and inside surface resistance. So this is outside surface resistance, and this is inside surface resistance. So please calculate R total. R total again is a combination of each layers. So you need to find R value of each layers. Yes, so you need to, for example, this is a brick wall. You need to calculate R1, R2, R3, R4. Okay. Okay, ada student dah jumpa jawapan very fast. 1.987. Okay, we wait one more person to confirm your answer. So R total is 1.987 meter squared. Meter squared. Kelvin per watt. Okay, so Haziq sama. Okay, Rifka sama. Alright, okay. So let's see. Let's see. Alright, let's me make a table. Easier calculate. What you have to do now is table. So material. Okay, for example, material plaster. Material plaster thickness D. D is 0 or convert to meter 0.025. Okay. K value is 0.95. Okay, can you calculate for me? So R equal to plaster berapa? Kita sama-sama lah bantu yang belum kira tu, yang kurang jelas. Okay, 0.026. 0.026. But remember, okay, plaster ada dua. Plaster have two place, inside and outside. So plaster number 1, plaster number 2, similar. 0.026. And then number 3, we have brick. Brick is 0.1 and then 1.1. So we can get brick berapa value dia? R. Okay, 0.091. 0.091. Last but not least, we have insulation. Insulation, which is 0.05 meter divided by 0.03, very small K value. We can get what for insulation? R value? 1.667. All right, thank you very much. Okay, last but not least, okay, don't forget to include surface out resistance and then surface in resistance, which is here 0.055 and 0.148. Okay, are you sure this is 1.987? Betul lain 0. Okay lah, okay, let's me calculate lah Alright, again 0.026 plus 0.026 plus 0.091 plus 0.667 plus 0.05 plus 0.44. 2.03. Okay, all right. Okay, so 2.013. All right, so be careful. Kenapa jam ni? Allah. 2.013. So mana? Where do you have dekat mana silapnya? Terlupa nak darab 2. Ni. Kan? Alright, so remember we have to calculate each layer because each layer will become a resistant. Okay, heat will transfer through each layer. Okay, so this is how you calculate. And then by the way, just in case for actually my for a report, for actual report, my susunan arrangement is not good actually. But if you in future, if you want to submit for green building summation, they will see your arrangement of layer. So the best way is to start with surface outside resistant, and then number 2 plaster out, and then number 3 brick. So the arrangement must be logical. Number 4 must be insulation. Number 5 must be plaster in. Okay, for example, this one. We have to follow one by one. For example, this is out, this is in. Firstly, we have surface out, and then plaster. Number 2, number 3 brick, number 4 insulation, number 5 plaster, number 6 surface in. Okay, some, for example, green building index, they also see your adjustment of layer. Surface surface in. Okay, so and then you calculate. This in term of to make a professional report lah, to show your submission. Uh, Maybe some of you will submit, maybe of not. But if you in future you work with a company that want to make a green building assessment, green building accreditor, if in case you need to submit, please make sure you arrange properly. All right, that is about okay, what we already learned, which is K value, R value. So you already expert in here. Another thing, we have U value, okay, which is thermal transmittance. Okay, thermal transmittance. So the equation is U equal to 1 over R. This is for single piece, or 1 over R total if several layers. Okay, for example, one single of brick, if brick, 1 over R brick. Okay, or if there is a wall, okay, 1 over R total of wall, several layers, plaster and so on. Okay, so that is how to use U value. Let's see if there is a definition of U value. Okay, U value. Okay, U value of a construction is defined as a quantity of heat flow through a unit area of building section under steady state condition. So basically, almost similar to R lah. R is how many resistance as a unit of layer. Okay, but U is in different perspective. We can say that, right? For example, one object has several X resistance, R value of X. Okay, so another way of express the heat properties of the material is we can say that the object has a U value of X. So we know in terms of U value, we will know how many. U value is watt per meter squared Kelvin. How many watt can transfer? For example, U value of 5. It means 5 watt can be transferred through the single material or through the layers of material. Okay. Meanwhile, R value is we say about, okay, that material or that combination will create R value of 5, resistance of 5 watt, okay, watt meter squared per watt. But in terms of U value is different perspective of explanation. But normally, if you find catalog of material, for example glass, for example, in terms of building specification, normally we will use term of U value. What is U value of the wall? What is U value of the door? What is U value of the windows? Okay, so normally we want to use U, but to get U value, we need to find R value first. Okay, okay, then let's look back at this question. So we know U value. Again, U value can be calculated for 1 and R total. Okay, one thing, when to calculate U value, okay, for example, layer, this layer one, R1, R2, R3. Okay, to use this equation, actually, it is 1 over R total, okay? For many layers, it is 1 over R total. It means U value equal to 1 over R1 plus R2 plus R3. This is correct. Not correct. It is not like this. U is 1 over R1 plus 1 over R2 plus 1 over R3. This is not correct. If you calculate one by one and then you summarize, it will bring different result. So you need to total up first and then divide one divide by the total. So this is the way to calculate R total. Okay, U value. So let's visit this question again. Uh, so what is the U value of this wall? Okay, maybe it's very straightforward. We already calculate R total. So U value is 1 over 2.013, which is 1 over 2.013. Okay, we can say that 0.497 497 watt watt per meter squared Kelvin. This sebaliknya je. Okay, 0.947. Okay, another question is actually all right, that is until now. Until now, is it okay? I think we take a rest first. We take a rest 5 minutes. So what you already covered is okay, we have a building that, okay, remember the purpose of this is we want to know heat transfer to the building, right? How many heat can be transferred? So we want to calculate the building properties. So the building properties, to calculate the building properties, we need to know K value, R value, and U value. Because in the end, we want to know how many heat can be transferred to the surface of wall. All right. So we take rest 5 minutes first, and then we continue again. So we continue at 3 minutes lah, 3 minutes. 3:21 lah, 3:21. We continue again. Okay, is it okay if I continue or you dah penat semua? Saya cuba kejar masa Boleh tak silakan? Boleh Alright. Okay, you dah kenal K value, you already know. R value, you already know. U value, you already know. But there is one thing which is U average. Okay, what is U average? Okay, this U value is about when you imagine there is several layers. of wall construction, and when you see at the other sides, is consists of similar material. For example, this wall, all layers is have these 3 layers lah, similar. 3 layer ni, dia punya permukaan wall dia adalah macam ni. Semua sama, similar material. Okay, what happen if the wall is like this? Okay, still have a plaster and then wall, a brick. The plaster, brick, okay, the 3 layers, but have also door and window. Okay, have doors and windows, so macam ni. Okay, so the 3 layers is very thick, but the windows is only 1 layer, very thin. Okay, and the doors is maybe this example. Okay, this example doesn't have doors. Okay, imagine only have a windows, but the windows and wall different thickness. Okay, so basically in this case, if we want to calculate U value of the whole wall, okay, so we need to use this one, average U value. When a wall is composed of different construction material with different U value. So we need, this is salah. So A1 is area 1 of U1 plus area 2 of U value type 2, and so on, and then total area. Okay, so basically, for example, this example, so we have 2 types of different layers. So for example, brick wall, U values, the V value are, so brick wall is 0.95 and the windows is 2.8. So it means we have a U value brick, which is 0.95, and U value glass, which is 2.8. And then we have an area brick, 8 meters squared, and area of windows, which is 2 meters squared. Okay, normally how to get this U value? We need to calculate one by one. So U value glass need to calculate, U value brick wall need to calculate if have several layers. So then we have 2 types of U value. So when we have this, to calculate overall or average U value, we need to use this equation, right? So it means 6. 8 minus 2 is 6. So brick wall area is 6, A brick wall, and U value of brick 6 times 0.95 plus area of windows and U value of windows 2.8. And then when we solve this, we can get 1.413, the average. Okay, so you get the idea, right? Okay, so let's see this question. Let's do this question, right? So this question have a wall, through 3.2 times 4.5, and then we have windows. Okay, so composition of the wall is 6mm glass window, and then 200mm of brick wall, covered by semi-plaster finishes on both sides. Determine average. Okay, so from this information, you need to calculate R brick wall first. Okay, step number 1. And then number 2, U of brick wall. And then number 3, R value for windows, then U value for windows. Number 4, area for wall. And then number 5, calculate area of window. Okay, from of this, you can calculate average U value, U average. which okay, try to find. So this mean brick area brick wall times u value brick wall multiply sorry, and area of glass u value glass, and then total area, so you can get. Okay, in this case, because I didn't inform about surface temperature, normally actual condition, again, we need to consider surface temperature, surface resistance, okay? But in this example, ignore. Please ignore to simplify things. Ignore surface resistance, okay? Okay, please calculate here, this. Find the average U value.
Doktor nak tanya, untuk yang R untuk glass window tu sebenarnya dia dah dikirakan yang 0.45 tu.
Okay, untuk soalan ni R
R untuk glass.
yes, R tu dah digirakan. Untuk glass window tu ya kena hati-hati ya. Kadang-kadang saya trick. Saya bagi value that unit. So unit tu apa? So tak payah kira lah.
Okay, dia kira tu.
Alright. Again, similarly in this question is degree Celsius. So just ignore degree Celsius because normally in this calculation degree Celsius we can assume equal to Kelvin, right? And don't worry about degree Celsius. Okay, ada sesiapa yang dah dapat jawab? Any of you have managed to find the answer? Layer plaster. Kami lupa. Oh, okay, sorry. Okay, we have a titip around 20 minutes or 15 minutes more for class. So hopefully I can cover all the calculation for chapter 2. Just next week, we can go to chapter 3. Layer plaster. Okay. Kalau dah dapat, tuliskan dekat chat box. By the way, if you have any question, you can ask me. No problem. Let's try to solve everything today. Okay. Okay, berjaya jawab. Dapat tak? Kena kira sama-sama. Okay, brick wall. Brick wall ada. Okay, first kali ignore surface resistance in this example. So we have R brick wall, which is 0.2 divided by 1.1 plus 0.015. 0.015 divided by 0.18 times 2. So R brick wall equal to 0.18 so itu 8. Okay, R brick wall is this one plus 0.167. Okay, around 0.349. 0.349. Okay, let's check sama tak? 0.349 if we ignore surface resistance. Sama okay. So, and then U value equal to 1 over 0.349, which is 1 over 1349, 2.87 lah, 2.87, 2.87. And then Windows R value is 0.45 already given. So U value is 1 over 0.45. 1 over 0.45. 2.22. So U value is 2.22. So we already get U value of brick, U value of glass. So okay, calculate for me the area. Area of brick, area of window. 0.9. I think I can calculate. 2 times 0.9 times 1.2. So 0.9 times 1.2 times 2. We have 2 windows. So area is
2.16.
2.16.
Yes.
Malas nak kira lah. Okay, 2.16. Alright, and then the brick wall area will be 3.2 times 4.5 minus 2.16 meter squared. Okay. Berapa?
12.24.
12.24. Alright, thank you very much. So we have, okay, for brick wall, 2.87, okay, U brick, and then area of brick, 12.24, plus U A brick wall. And then this is 2.22 times 2.12, 2.16. Okay, U glass, area glass, and then divide by just 12 and 24 plus 2.16. Okay, calculate for me, and then we can share to others. U average. All right. Okay, final answer. Okay, we have 10 minutes more. Hopefully, it can cover. Mm-hmm. 11.74. Okay, haikal itu 11.74. Okay, hopefully correct. Salah ni rasanya. Dia sebab the average. Average ni biasanya 2 point lebih lah. Kita boleh cuba lagi. So kalau ikutkan Haziq, 2.77. 0.77. Alright, okay. When we say average, if we say U value ni 2.8, ini 2.2. So basically average pun mesti dalam 2 point lebih lah. Yeah. Alright. Okay, Ikmal 35. So kira-kira balik Ikmal. So dia around 2.77. So ni 2.87, 12. Okay. So nanti bila kira balik. Alright. That is the principle of calculation of U average. So later I will give exercise. You can make exercise. Okay, last but not least, we going back. Alright. Okay, so we calculate. Okay, we already know to calculate K, R, U average. Last but not least is Q. Okay. Heat flow through wall. Okay. Q is K A dt over D. Okay. K A dt is temperature difference. This is quite easy. You just need to remember the equation. Again, heat flow or heat flux. Heat flux is Q Ka dt over d. Heat flux means if we have a surface, some surface area with some area, so how much, this is for example outside and inside. So outside have for example 35 degrees Celsius, inside has 29 degrees Celsius. Indoor, for example, indoor, outdoor. Okay, and this is wall. So we want to know heat flux from outside to inside. So we need to know the K value, area of the wall, and then temperature difference outside and inside, and divide by the thickness of the wall. I think here has the some equation, some, okay, this one. And this slide has the, okay, in case of this, because of this exercise, it says K only one layer. Wall has thermal conductivity of K of 70 watt and thickness D of 50 millimeter. Surface area 1 by 1. Temperature different. Temperature one side is 150 and another side is 80. So calculate the conductive heat transfer, or conductive heat transfer, or we call it as heat flux. Heat flux. So you can use this equation. Q equal to K area of the wall. dt is temperature difference. Sorry, outside and inside. Divide by 0.05. All right, 0.05 thickness of this, only one layer of material, 0.05. So you can get 98,000 watt or 96 kilowatt. So 98 kilowatt heat can be transferred into the wall. Okay, but this example is only for one layer. Okay, one layer material, one type of material, 7 K value and thickness. So if one layer, we can use this equation, heat conductance Ka dt over d. D is still in meter. dt is temperature difference, delta T lah. Alright, but if have several layers, okay, when we see this one, K over D, what is K over D? Okay, let's put pick outside. K over D. Okay, if we terbalikkan, K over D, it's actually 1 over R. So equal to U. Alright. So what we can say, Q is U A dt. Alright. Number one format of equation. Number two, okay, what can we use with this equation? Because the U, okay, in case if our U value is based on R total, okay, several layers. So for several layers, we have R total, right? So R total, we can derive U value total or U value from R total. Okay, so we can calculate the Q by using Q U A dt, right? So if you already calculate U value here, for example, U average, either U average, either U average or U with layers here, you can use directly to the equation. For example, this one. So calculate the Q if the area is 1 meter square and temperature different, for example, 3 degrees Celsius. Okay, outside minus inside. So Q is UA dt, which is U is 0.497. Area is 1 and temperature difference is 3. You can get the how many watt. Similarly with this one, after finding, so we want to know the heat transfer, the Q, heat flow through this surface. So this surface has wall and windows. So to know how many heat will be transferred. So we calculate U average first. Average U value of this wall. So we obtain U average, and then we can calculate the Q, which is U average A of the wall, and then DT, temperature difference. If given temperature difference outside and inside. All right, I think that's all for today. Hopefully you can manage to absorb all the information. But if you have any problem, I will provide exercise, and then when you make the exercise, if you have any problem, you can ask me. All right. So hopefully all is okay, and then I plan to stop here. All right, and then we will continue by next week. We will make tutorial for this course, and if you have time next week, we will go to chapter 3, natural ventilation. All right, thank you very much for attending. I think attendance is full today. Sorry, we have question. Heat flow symbol is Q or Q? We can use Q equation. Q. Big Q or small q is okay, as long as the unit is okay, is all right. Let's see, if I'm not mistaken, is okay. We will use Q, right? Small q with the unit of watt or kilowatt, right? Sorry, there is a question from student. Okay, is there any other question?
Sorry, doctor, I was late to attend the class. I didn't scan my attendance.
Siapa? Who is that? Muhammad?
Muhammad Abdurrahman.
Okay, I already update.
Okay. Thank you, doctor.
Okay, no problem. Okay. Alright, ada lagi? Okay, can you share the slide? Of course, I will share the slide after this. Alright. So the slide and this sketch. This sketch also I can give. So you can answer this question. This is related to Q. Okay, heat flow. Alright. So without further ado, thank you very much for attending. Thank you for very full feedback, very active in the class. So let's meet again next week. Thank you very much. Assalamualaikum and good days. And happy breakfasting later. Right?
Thank you, Doctor.
Thank you, Doctor.
Enjoy your day, Doctor.
Thank you, doctor.
Thank you, Doctor.